Hello everyone, my name is Masato Miyama, and I'm from the Graduate School of Dosha University in Japan. Today, my presentation will be about location estimation algorithm using UAV for real environments. I'll begin with the background. Large-scale disasters frequently occur in Japan. In the event of a disaster, if there are restrictions on ground rescue operations using small unmanned aerial vehicles (UAV) to locate victims is promising. One victim search method using UAV observes the probe request periodically sent by the victim's Wi-Fi terminal and estimates the terminal position from the received signal strength indicator (RSSI). RSSI is a value that represents the strength of the signal received by the wireless communication terminal. In an actual environment, RSSI encounters problems such as unstable numerical values and irregular transmission intervals due to the influence of the obstacles and the surroundings. Then, we probe the method to estimate the position from the deviation of the RSSI measured at several points for situations where it's difficult to accurately predict the position of the terminal from the RSSIs that are deteriorated due to the influence of the obstacles in the real environment. And next, I will explain our method. The figure 1 is proposed algorithm image, and figure 2 is overall flow of the proposed method. Proposed method consists of 5 major steps. First, set a square Sn that includes the start point of the vertex and has measurement interval d as the length of the one side. 2. Measures RSSI at the unmeasured point of the set square vertices. 3. Compares RSSI at 4 vertices of the set square and newly set the square Sn plus 1, which is the point symmetric movement of a set square, with the maximum point was a symmetry point. 4. Calculate the deviation of the 4 RSSIs measured in 3 and compare the deviation of Sn and Sn minus 1. Change if significantly different. First, 5, when the RSSI of the measurement point exceeds minus 50 dBm. It is assumed that the victim's position is specific. If not, go back to 2 and try again. Next, I will explain evaluations. To evaluate the algorithm, the length of the measurement interval t was changed and examined in a real environment. Used two methods in the experiments, the previous research and the proposed method. The RSSI measurement time for one block was 15 seconds. The length d of the one side of the square, which is the measurement interval, starts at 5 meters. In the previous research, the search was always done at d equals 5 meters. In the proposed method, we use two approaches. One is to change d equals 5 meters to d equals 2.5 meters at the time of the change, and the other is to change from d equals 5 meters to d equals 10 meters at the time of change. Next, I will explain results. Figure 3 shows the result for the park. Figure 4 shows the parking lot result. It shows a total of 3 search times and success rate for the previous method and proposed method. Comparing the responsive search times, the proposed method takes less time than the previous method. Comparing the two proposed methods. Proposed method D equal 10 meters had a good success such time, while proposed method D equal 25 meter had a good average such time include failures. It can be said from the result that the proposed method D equal 2.5 meter is a balanced method. When comparing the success rates, the proposed method showed a better result than the proposed method. There were no significant change in the success rate between 2.5 meter and 10 meter, but in some cases it failed. And next, I will explain every discussion. From the result, it can be said the proposed method equal to 5 meter is a well-balanced method, but proposed method equal 10 meters successful such time result was better. It is advisable to use a well-balanced combination of equal to 2.5 meter and equal 10 meter. When the distance to the terminal is within 5 meter, minus 50 dBm or more is measured. So the goal of discovery of the victim was minus 50 dBm. However, in reality, it is conceivable that the RSSI will be significantly reduced due to obstacles such as rubble, and distance to the terminal will be minus 50 dBm or less, even within 5 meters. And next, I will explain conclusion. Future taxes, redetermination of surge end conditions, using a well-balanced combination of equal 2.5 meter and equal 10 meter. Thank you for watching.